Hello learners, myself Dr. Renuka Mainde, corporate nutritionist and counselor in IGNOU for their MSc Dietetics and Food Service Management course. Learners, today in our continuation series of bioactive components of spices, we will be learning about Trigonella Ffn Graecum, commonly used spice popularly known as fenugreek seeds or methi dana. The objective of this module is to understand and learn about the wonder spice fenugreek. In this module, we will be learning about general properties, phytochemistry and effect of processing on fenugreek seeds. Fenugreek, the botanical name is Trigonella Ffn Graecum, is a yearly plant that has its place in a family Leguminosae. It is a well-known spice in human food. The seeds and the green leaves of fenugreek are both used as a food as well as a medicine, which is an old practice of human history. It has been used to enhance the flavoring and the color. It also modifies the texture of food material. Fenugreek seeds have medicinal properties such as hypocholesteremic agent, helps in good lactation, antibacterial, gastric stimulant for anorexia, anti-diabetic agent, galactagogue, hepatoprotective and anti-cancer effect. These positive functional effects, including the anti-diabetic and hypocholesteremic effect of fenugreek, is mostly attributed to the inherent dietary fiber constituent, which has a favorable nutraceutical value. It is well known for its fiber, gum and other chemical constituents as well as volatile contents. Dietary fiber of fenugreek seeds is about 25%, which changes the texture of food. These days, it is used as food stabilizer, emulsifying agent due to its high fiber, protein and gum content. The protein of fenugreek is found to be more soluble at alkaline pH. Fenugreek has a beneficial effect on digestion and also has the capability to modify the food. Learners, we begin with phytochemistry. Fenugreek stem encompasses a number of steroidal sapogenins. The diosgenin is present in oily embryo. The alkaloid trigonelline, trigocoumarine, trimethylcoumarine and nicotinic acid are present in stem. Mucilage is noticeable compound of seeds. It also contains 22% of protein. Volatile oil contains two alkaloids, trigonelline and choline, and yellow coloring substance is present in stem. Let us now learn about the leaves. Leaves contain saponins known as graceunins. These compounds are glycosides of diosgenin. Leaves contain moisture 86.1%, protein 4.4%, fat 0.9%, mineral 1.5%, fiber 1.1% and carbohydrate 6%. The mineral and vitamin contained are calcium, iron, phosphorus, carotene, thiamine, riboflavin, niacin and vitamin C. Fenugreek seeds. Let's understand the morphology of seeds. The morphology of seeds, it appears solid rhomboidal seeds. It measures around 3 to 5 mm long, 2 mm thick. The seeds are hard and pebble-like. The color of the seeds is yellowish brown or light brown. Odor is spicy and the taste is bitter. Fenugreek seeds are aromatic, bitter, carminative, antibacterial and it can be eaten raw or cooked. The bulk of these seeds is dietary fiber 50% and protein 30%, both of which have no taste or flavor. The chemical constituent of fenugreek seeds include large carbohydrate fraction, mostly mucilaginous fiber and galactomannan, 20 to 30% proteins high in tryptophan, lysine, pyridine, type alkaloids, flavonoids, free amino acids, 4-hydroxyisoleucine, arginine, lysine, histidine. Saponins are mostly saponins, glycosides, vitamins, minerals. The bitterness is mostly due to the oil, steroidal saponins and alkaloids, traditionally used as culinary and medicinal herb. Recent examination studies have shown its efficiency in reducing blood glucose levels, promoting lean body mass, lowering cholesterol and treating gastrointestinal disorders. Seeds contain 0.1% to 0.9% diosgenin and are extracted on a commercial basis. Plant tissue culture from seeds grown under ideal circumstances have been found to produce as much as 2% diosgenin with a similar amount of getogenin and trigogenin. These seeds also contain saponin, fenugreek. Numerous coumarine compounds have been identified in fenugreek seeds as well as number of alkaloids. A great amount of trigonelline is degraded to nicotinic acid and related pyridines during roasting. These degradation products are in part accountable for the aroma of seeds. Let us now learn about fenugreek gum. Fenugreek gum is derived from endosperm of the seeds. It contains galactose and mannose. It gives a high viscosity in the aqueous solution. Fenugreek gum is used for thickening, stabilizing and emulsifying food agent. Fenugreek gum is less exploited in food industry as compared to other gums such as guar or the locust bean. The oil content of fenugreek seed is almost 6 to 7%. The oil is mostly unsaturated and include oleic, linoleic and linolenic acid. The fenugreek seed also contain oleamide around 1.8 mg per 100 grams of seeds. In the experimental studies on mice, oleamide has shown to be beneficial in controlling Alzheimer's disease. Let us now learn about effect of processing on fenugreek seeds. The seeds are bitter in taste because it contains saponins which limit their suitability in the food. It has been possible to debitter fenugreek seeds by applying various processing methods such as soaking, germination, roasting, etc. As the fenugreek seeds are rich in mucilaginous fiber and other dietary essential, its use can be explored as functional food, nutritional food and also as a therapeutic agent. Let us now first understand soaking. Soaking of fenugreek seeds has been reported to decrease fat content to around 4.6% and significant increase in protein content. Marginal decrease in total carbohydrate was observed. Appreciable decrease in total dietary fiber, insoluble fiber and soluble fiber was observed by almost 3 to 4%. This decrease might be attributed to enzymatic degradation of seeds during soaking. The phenolic content increased from 45.4 to 54.4 mg. In response to phenolic content, antioxidant activity increased significantly after soaking from 18.1 to 60.7%. In general, soaking did not show any significant change in total ash. Phytic acid content decreased significantly after soaking, which is ultimately caused a significant increase in vitro starch digestibility and in vitro protein digestibility. Let us now learn about germination. Germination of fenugreek seeds has been reported to result in reduction of fat content as compared to its raw seeds. Loss of fat during germination may be due to its consumption as energy source in the process of germination. The protein content increased from 32.7 to 41.2% after germination. This increase might be due to decrease of seed nitrates into protein. Increase in protein content may also be because of enzymatic synthesis of protein. Increase in crude fiber content, a major constituent of cell wall, upon germination might be attributed to synthesis of structural carbohydrate such as cellulose and hemicellulose during germination. There was a marked reduction in total dietary fiber content, insoluble dietary fiber content and soluble dietary fiber content upon germination. Reduction in dietary fiber content after germination may be attributed to enzymatic breakdown of galactomannan units during sprouting. During sprouting, enzymatic hydrolysis of phytate phosphorus takes place, which decreases phytic acid content. Roasting. Roasting was shown to decrease the fat content by 4.5%, whereas there was a noticeable increase in protein content. Effect of roasting upon the fat content of beans is to reduce its actual weight with the shrinkage. Some of the more volatile fatty acid are driven off and fats are broken down to give a greater percentage of free fatty acid, some light esters, acrolein and formic acid. Reduction in fat content upon roasting may be due to loss of volatile oils on open dry heat treatment. Nutritional and therapeutic quality of fenugreek seeds can therefore be improved through processing methods like soaking, germination and roasting. Antioxidant activity also increases significantly after processing, which is found to be responsible for medicinal properties of processed fenugreek seed flour. Therefore, use of processed fenugreek seed flour can be explored in functional food as well as a therapeutic agent on a regular basis. Let's conclude, learner. Over the previous few years, many studies have been performed on medicinal and functional properties of fenugreek seeds. Fenugreek is rich in fiber and protein, and due to its appreciated bioactive component, it has a hopeful therapeutic applications. Anti-diabetic, antioxidant, anti-carcinogenic, hypocholesteremic effect are the major medicinal properties of fenugreek as established in diverse studies. Based on this healthy benefits, fenugreek can be suggested to be a part of our daily diet and incorporated into food in order to produce functional foods.